Welcome to Unit 4, Lesson 7, Part 2. Today we're going to be multiplying with decimals in both of our factors. Open your workbook to page 138. Today we're going to be discussing shifts when both factors are decimals. So we're going to be multiplying by a tenth. Think about what it means to take 1/10 of another part. You can think about money if you like. Okay, so let's use money. Let's say we have a dollar bill, $1, and we wanted to break this or divide it into 10 equal parts. If you were going to divide a dollar amongst 10 people equally, how much would each person get? Well, dividing a dollar is simply the same as dividing 100 pennies or 100 cents by 10, and that would get you 10, and 10 cents is a dime. So each person would get 1 dime. And there would be 10 dimes to go around, and there are 10 people, so it works out nice and evenly. Now, we just said that a dime, 1 dime, is equal to 1/10 of a dollar. So how much is 1/10 of a dime? Well, if you took a dime and had to break that up and divide it equally amongst 10 people, each person would get how much? It would be 1 penny. There would be 10 pennies and a dime and 10 people. So again, it fits nice and evenly. Each person is going to get 1 penny. Now what we have here is a situation where we took a tenth of a tenth. We started by taking a tenth of a dollar, so our dime was 1/10, and then we took a tenth of the dime. This is the same as to say that we took a tenth of a tenth. We first took a tenth of our dollar, and then we took a tenth of our dime. So we took a tenth of a tenth. Of means multiply, so if we were to multiply these two fractions, we would see that a tenth of a tenth is 1/100th. It's not just a coincidence that 1/100th kind of matches up with how many pennies it takes to make a dollar. It takes 100 pennies to make a dollar, and if you just had 1 penny, that would be 1/100th of a dollar. So let's say that I have an object here, a rectangle, and I've cut it into 10 equal pieces. Each of these pieces represents 1/10. Now I'm going to take one of those tenths out. I'm just going to take this one out, and I'm going to enlarge it so you could see it under a microscope. And I'm going to break this tenth into 10 equal parts. 1, 2, 3, 4, 5, 6, 7. We're pretending they're equal. 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, if I did that, that would be like taking a tenth, which is what I started with, 1/10, and dividing it into further tenths. If I did that to each and every one of these cells, each one of these were divided into 10 equal places, then my entire whole unit here would not be 10 pieces anymore. It would now be 100 pieces, or 10 plus 10 plus 10 plus 10, 10 times, or 10 times 10, which is 100. This is further proof that taking 1/10 of 1/10, which is exactly what we did, equals 1/100th. We took a tenth of a tenth. And this just means that one of these in here, any one of these cells, is equal to 1/100th. Each one of them is 1/100th. So 1/10, this is a tenth, of a tenth, this tenth up here, equals 1/100th. Well, if 1/10 of 1/10 is 100, then what is 1/10 of 4/10? You might be thinking 4/100ths. And if that's what you're thinking, let's check that. And let's use the traditional method to check it. 1/10, 0.1, times 4/10, 0.4. We're going to ignore both of our decimals here. In the back of my mind, I know I have 2 decimal places, and I'm going to be needing to move my decimal 2 times. But for now, I'm just going to ignore them. 4 times 1 is 4, and there really isn't anything left to do. 4 times 0 is 0. We could put the placeholder and do double digit, but you can see that you're still going to be left with 4, a couple of zeros in front of it that are not needed at this time. But you will need them when we place our decimal. We have 2 decimal places total. We're going to bring our decimal out where it always is on the right. We're going to move it where we always move it to the left 2 times because that's how many places we have. So we are going to need those zeros. If we hadn't put those zeros, we would just add them because they're not changing the value of the number. Zeros in front of the 4 doesn't change the value of the 4. 4 is still 4 whether it has zeros in front of it. But when we put the decimal in, now we've changed the value. It's not 4 anymore. It's now 4/100ths. So if you were thinking that a tenth of 4/10 is 4/100ths, you're correct. Number 27, you have 1/10 times 4/100ths. You're going to place your answer there. What is 1/10 of 1/100th? 1/10 of 1/100th is what they're asking you first, and then you could just expand on that and probably do it mentally to figure out what 1/10 of 4/100ths is. And again, you can think about modeling on this. 1/10 of 4/100ths. So modeling may be a little difficult here because you're going to have to create hundredths, but you can start to model and probably mentally pick it up from there. In other words, you could create a rectangle and you could think about what it would take to create hundredths in this rectangle. You would need 99 of these lines, and I'm not going to create 99 of these lines, but you would need 99 of them, and you would have 100 equal places. That would get you hundredths. You would need 4 of those hundredths, so really technically 1, 2, 3, 4. I only need 4 of these hundredths. I'm going to pull 4 of those hundredths out and focus on those 4. I'm going to take one of my 100ths out, make it large, and look at it under a microscope. I'm just going to take one of them. This is equal to 1/100th, 1/100th. And I'm going to break that into 10 equal places because I want to know what 1/10 of all 4 of those hundredths are, so I'm going to start creating my 9 lines. 2, 3, 4, 5, 6, 7, 8, 9. So I took 100th and I cut it into 10 equal places. You can imagine how many equal places you're going to have if you did that to each one of these cells. If you did it for each and every one, which you will have to do, in your head at least, you're going to have to take each cell and make them equal. And since you just cut this one into 10 equals, you'll have to do the same for all of those. And if you did that, how many equal parts would you have in this entire whole rectangle? The entire thing would be not hundredths anymore because you took each hundredth and broke them into 10 more. So it would be now thousandths. You have now 1,000 equal pieces. So now if you take 4/10 of those thousandths, 4 of these rods, you would have the equivalent of 4 thousandths. Because you're only taking 4 out of a whole unit that's broken into 1,000 pieces. And taking 4 out of 1,000 is 4 thousandths. That can be written as a fraction, 4 over 1,000, or it can be written as a decimal, 0.004. We can check this by multiplying the traditional way. Let's do that. We're going to take our 1/10 and multiply it by 0.04, which is 4/100ths. We're going to multiply our whole numbers. 4 times 1, which is 4. We learned from the last one that adding all these zeros isn't necessary. We may have to add some zeros at the end in order to move our decimal, but it isn't necessary to add them yet. And now we're going to go count our decimal places. We have a decimal here, and we have one here. I'll make it more visible. We have 1 number here and 2 here. That is a total of 3 decimal places. So we're going to move our decimal 3 times. We must first bring it out, make it visible, bring it out at the end of the whole number, and then we need to move it 3 times in the same direction we always do. 3 times, 1, 2, 3. And because I have no zeros or any digits here to move it, I need to add zeros. And we are used to adding zeros where there are no numbers. We're going to put the decimal right there. We could add a 0 at the beginning if we want. And again, we see that we were correct, that our answer is still 4 thousandths. You can go on to do number 28. How many places did the 4 shift each time you multiplied? Notice that the 4 is in a different location than where it was when we started, when you were just looking at the factor. In this situation, it was here, one digit after the decimal in the tenths place. And afterwards, how far did it shift and which direction? Take a look at the 4 here. It's 2 digits after the decimal place and the hundredths place. And after we were done, it shifted. It's not in the same place value. It shifted one direction, and how many times? That's where you need to put your answers for number 28. Number 29, look at your answers. What patterns do you see in the number of decimal places in the products? That's the answer. How is it related to the number of places in the two factors? We've been talking about it. How is the number of decimal places in your two factors similar or different to the number of decimal places in your answer or your product? Now I would like you to complete all questions up to number 34 and then come back for the rest of this lesson. We're going to skip number 35 for now and go on to 36 through 47. 36 says, use the shift pattern to solve these multiplication problems. Because these multiplication problems are using whole numbers that are really simple enough for you to multiply in your head, there shouldn't be any work for any of these problems. To give you an example, in number 36, you're simply multiplying the two whole numbers you see, which would give you 8. And now comes the time to count the number of decimal places there are in both factors and move the decimal appropriately. There are 2 decimal places. We're going to bring our decimal out and move it 1, 2 times. We're going to need to add a 0 and put our decimal here. So all of these here could and should be done in your head. Even some of these ones down below, for instance, number 45, 13 times 2, you could probably do in your head is 26. Remember, we're just ignoring the decimal, and now we're going to go back and count all the decimal places with both digits. There isn't a decimal in the 2, so there's only 2 decimal places. We're going to bring that decimal up and move it 2 times. So you could get away without doing any work and probably should not have to do much work here, and the key to the entire lesson here is to make sure that your decimal is in the right place. Page 140 offers similar type problems and the same degree of difficulty for the most part. Some of these digits are a little bit larger. They could be solved the traditional way if you need to. Some of these digits are even written probably not in the easiest way. For instance, number 58 would probably be easier if you wrote it in a reverse order. So let's do that. Number 58. We'll rewrite that. And the reason why I want to rewrite that is I have 2 digits that I need to multiply on the bottom and only 1 on top. I prefer to have only 1 on the bottom, which makes single digit multiplication. Also, 26 times 2 might be able to be done in your head, but if you can't, you definitely want to reverse it and do 2 times 6 is 12. 2 times 2 is 4 plus 1 is 5. There are a number of decimal places here, 2 in this digit and that factor and 1 in that factor for a total of 3. So we're going to move our decimal from the right hand side 1, 2, 3 times over in the same direction as we always do and place our new decimal there, creating an answer of 52 thousandths. That's 0.052. You may go ahead and complete the rest of this page, showing all work if necessary. Some of these I realize can be done in your head, and I would be proud if you did that in your head, but if you need to show work, go ahead and do so.